Welcome to video 15 in the Different Angle 3D video tutorial series. This is the start of the third practical project, and we'll build on the previous videos by looking at how to design steel fabrication, and I'm using a manual plasma cutting table as the example of the design thoughts I'm putting into creating this object. The table will be similar to you've just seen in the introduction animation. When you're designing any sort of work table or workbench, one of the key considerations is the height of the table compared to the user that's using the table. In industry, quite often they have adjustable workbenches that can be jacked up to different heights, but if you consider a person that's 6'2", they're going to need a totally different table height to somebody that's 5'2", and there could be as much as 300mm difference in table height requirement. Fortunately, with a DIY build, we're designing it for ourselves, so we can work out what's comfortable for us and set the table height to suit. If you don't get the table height right for the person that's using it, you can over time cause all sorts of health issues for them. If you're having to stoop and bend over, then the stress on the muscles and lower back can be quite damaging over a long period of time. So it's always worth taking the time to experiment and find out what works with you. When you're happy that you've determined what height you want the table for you to be comfortable working on it, we can open Blender and first of all put a representation of where the tabletop will be within the Blender 3D environment. So first of all, the default cube isn't that useful for it. It can be used, but I'm going to delete the default cube, so press X for delete and accept delete from the pop-up menu to get rid of it. And we'll add, by pressing Shift A mesh plane. At the moment it's sitting at world 0, so it's effectively on the floor of the 3D environment we're building, and I'm fairly tall, so for me a comfortable table height is 1 meter high. Other people, as I said in the previous introduction, it'll be either more or less depending on how tall you are. So I'm just going to use 1 meter high for the moment for the table that I construct, but I'd expect you to make it at the right height for yourself. So in the Add Plane panel, which pops up at the bottom corner, you've got an option for where the plane sits. At the moment, Blender, when it opens, is in the default of measuring in meters, and we can change that to millimeters, and most engineers tend to work in millimeters rather than meters. So you go into the scene panel on the properties window on the right hand of the screen and go to the units, and we can change all of the units in there. At the moment the unit of length is meters, so click on that and change it to millimeters, or if you're happy working in meters you just have to use a point whatever the millimeter is when you're putting numbers in. So the panel changes to give the millimeter suffix to the numbers, and we're going to change the Z position to 1 meter, so it's 1000 for the millimeters in there, and you'll see the plane has jumped up on the Z axis to that new position. If you want to change it as a later date, because as soon as you do another operation the add panel moves, you've got the option with the number keys by pressing N in the number panel, and you can see the Z position is at 1. So press N to toggle that back out of the way again. Or you could have done it simply by pressing G to grab the plane and move it on the Z axis 1 meter. There's always lots of ways to do things in Blender, but we've got a meter that is as default 2 meters square, sitting 1 meter above the ground plane, and to determine the tabletop size there's lots of things that can influence how big you want the table, depending on how big a sheet you want to work on, or whether you've got a certain space in your workshop that you want the table to go into. I've got a different thing where I've got 3 meters of 50 by 75mm box section, which I'm going to use as the 50mm as the horizontal width and 75mm as the vertical height of the box section when it's in place. And if I cut one in half to 500, it gives me a tabletop size of 1 meter by 600 out of those 3 sections if I cut one of the lengths in half. So we've got to now make the plane 1 metre by 600. So if we tab into edit mode, and I'm going to just for now put the edge length on by going into the overlays and clicking on edge length. So you can see it's 2 meters square, everything's selected, and the easiest way to change its size is to use the scale tool, and to do that we can scale the plane by 50% or 0.5 to bring it down to 1 meter square to start with. So on your keyboard press S for scale and 0.5 as the scale factor and then enter, and you can see we've now got it 1 meter square. We want it 1 meter by 600. So now we've got that size, we can scale it again, but this time just on the y-axis. So we press S for scale, then Y for the y-axis, and 0.6 to give it a scale factor that gives us 600 millimeters, and enter. So that gives us the scale factor, and for some reason the meters has defaulted back to the measurement is defaulted back to meters rather than millimeters, but we've got 600 millimeters by 1000, which defines where the top of the table will be. And what I'm going to do is just build a cube that defines the outer dimensions of the table to use as a reference when we bring the steel stock sections into the blend file. So it's sitting 1 meter above the floor, it's 1 meter in length and 600 wide. Now the bottom of the framework, I'm going to add some casters to mine so it won't sit directly on the floor. You have to compensate for the height of the casters. I've got some 100mm diameter casters which are good for rolling over fairly rough workshop floors, and they sit 130mm high off the floor. So we need to extrude this plane now on the z-axis minus 870, which will offset, leave you the gap for the casters underneath. So if we press E for extrude, sorry, bring that back into focus, E for extrude, minus 870 gives us a rectangle now that's sitting off the ground plane by the height of the casters. Now we can use this as the reference to build the framework, but as it sits at the moment it's not really much use because you can't see where you're putting the framework inside that effectively a bounding box of what we're building. So we can change the view properties of the object. If we go into the object properties panel on the properties window and go to visibility, and in visibility, first of all, we don't want this to be in any renders. This is just a reference for us to build the steel sections into. So straight away we can click or take the click out so it doesn't show in renders, and then in the viewport display, at the moment it's displaying as textured. We can change that to wire, so it will only ever show as a wireframe within the viewport, and it won't show at all within the renders. So if we just tab back into object mode, we've now got a frame that we can snap other objects to. Now's a good time to save your work, so press Ctrl S and just save the project to somewhere on your hard drive. While we've got the cube, which is effectively the bounding box of the area we're going to build the plasma table, the bottom surface would make a really good shelf to store equipment, and I'll be using mine to store my welding equipment, and you can prove out whether or not the shelf will be a suitable size, or whether what you've got will fit onto an area of a shelf you're designing, simply by making some fairly basic surface models of your tooling, just making them to scale. I've done that already for some of mine, and I'll append them in. So if I append in from welders blend file, and I'll bring in the collection, which is plasma cutter and a pen. The three welders were all in that collection. So we just go into the material view, then you can see the size of the equipment I've got will fit easily underneath the plasma table on the shelf that will be sitting on top of the casters. And you don't have to go to a lot of detail. I've gone to a fair bit of detail on the plasma cutter, putting a few logos and things on it, but it can be just literally a basic mesh model that shows you the basic shapes to roughly size. I'll just get rid of the edge length because we don't need it, or just a little bit of detail that you add in, or you could go the whole hog and put all of the welding cables and things and hooks where you'd expect them to be hanging on the frame. But it's quite a useful thing having the frame to work to and snap the steel sections to. And in the next tutorial, that's exactly what we'll be doing, is starting to build the framework, appending in some of the standard steel stock sections that we looked at making in the previous project. If I've skipped over anything that you don't fully understand, it's possibly because it's been covered in much more detail in either the previous projects or the getting started section. Like I never showed you how to save a file because it's done in the getting started section. So if you are unsure of anything, go back over the previous 14 videos. I'm sure you'll find the answer in there. Hopefully you're finding this useful, and if you are, don't forget to subscribe to the channel. Keeps me motivated to get on and make more videos. And in the next one we'll be looking at creating the top frame that the slats sit into to form the tabletop of the plasma cutting table. Thanks for watching, and see you again soon.